Let's look at the three example problems at the end of the notes. Hopefully you've gone through and you understand the relationship between energy and frequency. The first one says, calculate the energy in joules of an individual photon of yellow light that has a frequency of 2.76 times 10 to the 16 hertz. The formula for this energy is equal to H times F. H is Planck's constant and F is the frequency. We can substitute in and we have 6.63 times 10 to the negative 34 joules times seconds. That's Planck's constant. And then we multiply that by the frequency, which is our given there, 2.73 times 10 to the 16 hertz. Now remember that hertz, these units, are 1 over seconds. So 1 over seconds times seconds cancel each other out. So hertz cancels with seconds and it leaves us with just joules. When we do our multiplication on our calculator, remember 6.63, then we hit the second EE button and use the sign change button down at the bottom right corner to change it to a negative and then put it in your 34 times 2.73 second EE 10 and then plug in your 16 to get your times 10 to the 16th. The answer, when rounded to three figures, is 1.81 times 10 to the negative 17 joules. So that's our answer right there. Here we're going to calculate the frequency. So we just rearrange the above equation and solve for frequency, and that just ends up being frequency is equal to energy divided by H. So we can substitute in our given is the energy on top, 2.48 times 10 to the negative 14 joules, and H underneath Planck's constant, 6.63 times 10 to the negative 34 joule seconds. If we look and see what cancels, joules and joules cancel. We end up with seconds on the bottom, 1 over seconds in other words, which is another name for hertz. We do this multiplication and we get 3.74 times 10 to the 19 hertz. The last problem gives us a wavelength in nanometers. 10 to the 2 is 100, so 7.80 times 10 to the 2 is 780 nanometers. It asks us, if I can hold on to my pen, what is the energy? Well, this equation, the first equation, E equals HF, doesn't have wavelength in it, but we have an equation that does. C equals F times lambda. If I want to solve for F, I have F is equal to C divided by lambda. I can substitute this into this equation for F. And what I end up with is E is equal to C times H, or H times C. Let's do it that way. H times C over lambda. E equals H times C over lambda. And the top two numbers are just constants. So H is our 6.63 times 10 to the negative 34 joules times seconds. C is 3.00 times 10 to the 8th meters per second, and our seconds and our per seconds cancel. And then we need to divide by lambda, which is 780 nanometers. Well, here we run into a problem because nanometers and meters will not cancel. So we need to add a unit conversion here. We'll say 1 times 10 to the 9 nanometers is equal to 1 meter. And now our meters cancels with our meters, our nanometers cancel with our nanometers, and we're left with just joules, which means we must have done this correctly. So 6.63 times 10 to the negative 34 times 3 times 10 to the 8th divided by 780 times 1 second EE9, that's 1 times 10 to the 9th, and we end up with 2.55 times 10 to the negative 19 joules. So that's our answer there. Didn't box that one.